Hi, this is Levi Straight, and this is the area box problem demonstration for the TI Inspire. I'm making this demonstration because you need the TI Inspire computer software to actually run this document, or a TI Inspire handheld. And if you're not a mathematics person or teacher, then you probably don't have this. So enjoy the demo. If you do have it, you can download the document that I've included and play with it yourself. So the demonstration for the maximum area is just to show the slides basically, and then show the interactive spreadsheet and data capture that the students would use. So it starts out with the title screen, a couple of questions to kind of prime them about rectangles, so area and perimeter. And then it goes on to say we're going to connect the ideas of area and perimeter. So they've got a fixed perimeter. We're going to see what happens to the area. So the next 2 pages from now, we're going to slowly drag a flexible rectangle that has a fixed perimeter. And the next slide is going to ask the student to make a guess of what happens before they do that. So here's a question to answer. So here, and we're going to peek ahead. So I've got a spreadsheet set up that's going to capture the length, the width, and it's going to show that the perimeter stays at 40. And the students are going to come back and add column C to figure out the areas of the things that they've captured. So back to 1.7. I'm going to grab this point and drag it really slow. So the idea the students were supposed to answer is the area going to get bigger, smaller, stay the same, or do both? And so if they use mental estimation, they can look at the length and width and sort of check their idea before they get to the other page. Flip over. Okay. So we release. And we have a bunch of captured values. We have tons of data. So the student instruction was to name this column rectangle area, rec area, and do the column len times the column width, WID. And the reason for the different names is because length and width was already taken. So there's all the areas, and as you scroll down, there are a lot of data points. So the students should realize that the area went up as they got to a certain point, and then it started coming back down. Checking their guess. So this is the what if scenario. Discuss this with your group members. Go back and look at it, try to find the largest area and the dimensions, and see if it makes sense as far as it relates to perimeter and area. We're going to look at a scatter plot of this. So we're going to add, it doesn't matter if you add length or width, you do the same thing. So we get our nice graph, and we see that with relation to length or width, we get a nice parabolic graph. And somewhere here near the vertex is going to be the maximum area. So we round that, we find the maximum area is with a length and width of 10 and an area of 100. And we're going to find that out in the next couple slides. So wondering what is going to happen here with a fixed perimeter of 40. And we're going to derive the equation that we're going to use for this. So if we have a fixed perimeter of 40, we want to find out the area. So we're going to solve for either W or L, substitute that into the area function, and figure out an area equation that we can actually graph without having to capture all those data points. So we'll solve it algebraically. So this just goes through, if you solve for W or L, shows you that your area function is going to look pretty much the same. Just one of them has L as the variable and one of them has W as the variable. And then there's our equation. Go over and throw it on the graph. And you gotta change the window. And then we can analyze graph. Choose maximum. And we have to identify a boundary, so we have to do a lower boundary, a higher boundary, and automatically it puts our maximum down at 10, length or width, comma 100, that's the area. So the maximum area for a rectangle with a fixed perimeter of 40, because this equation is specific for a fixed perimeter of 40. And then from here the students will understand then how to create that equation with a fixed perimeter, then find out the maximum area, and that's going to be applicable to the project that is set up for them to make a dog pen with the maximum area. Given a fixed perimeter, the fixed perimeter is fixed because they have a limited amount of money that they can spend on the fencing. So that leads them to this.